We are now ready to take on some more examples. In this example on page 26, we are told that it is estimated that 8.3% of all Americans have diabetes. This means that in the general population of all Americans, the proportion or fraction of those who have diabetes is 8.3%, same as 8.3 divided by 100, and that would be 0.083. Now, we are to suppose that a random sample of 74 Americans is taken. So, we have n equals 74, the sample size, and we would like to compute the probability that the proportion of people in the sample who are diabetic differs from the population proportion by less than 1%. First of all, if we want to compute a probability associated with the sample proportion, we will need to get the sampling distribution of the sample proportion. So, what do? We will need to check the conditions we have checked so far. And that will be, step 1 will be to multiply n by p. That will be 74 multiplied by 0.083, which is equal to, this is equal to 6.142. You might observe that n times p in this case, unlike in the previous example where n times p was greater than 10 and n times 1 minus p was greater than 10, n times p in this case is not greater than 10. It is lesser than 10. What this means is that the sampling proportion does not have the normal distribution. With this given, it will not be possible to compute this probability. We will need to find other advanced technologies or methods in order to compute this probability, which is beyond the scope of this class. The point of this example is this, that whenever the conditions are not met, either NP is not greater than 10 or n times 1 minus p is not greater than 10, we should not continue to find the probability at this level with the methods we have learned so far. Rather, we should find other ways, and for the purpose of this class, that would not be the intention to take you past what we are supposed to just learn. In other words, this example will not be solvable as far as the methods in this class are concerned. Then, we proceed to the next example. A large car dealership claims that 47% of its customers are looking to buy sports utility vehicle, SUV vehicles. So, in the general population, P is equal to 47%. Now, a random sample of 61 customers is surveyed. So far we have the following details. Sample size is 61. The population proportion is 47% or 0.47. And we would like to find the probability that less than 40% are looking to buy an SUV. To find the required probability connected to the sample proportion, we will need to find the sampling distribution of the sample proportion, which can have the normal distribution only if certain conditions are met. So let's check the conditions again. We will need to first multiply n times p, which will be 61 multiplied by 0.47, and that is equal to 28.67. This is greater than 10, and so we can say that it checks out. Then 2, we have n times 1 minus p, that is 61 times 1 minus 0.47, which will give us 61 times 0.53, and that is equal to 32.33. This is also greater than 10. So since those two conditions are met, I am free to use the normal distribution to approximate the sampling distribution of P at. In which case, of course, the sample mean, or the mean of all the sample proportions, will be equal to P. P is equal to 0.47, and the standard error of P at will be P times 1 minus P divided by N, and then taking the square root of it. That will be 0.47. 1 minus 0.47 is 0.53 divided by the sample size of 61. This will be equal to, for the sum, let me think, I'll just write that down here. So the answer for the standard error is equal to 0.0639. So now that I have the parameters of the sampling distribution of P at, I can then proceed to find the probability that less than 40% are looking to buy an SUV. So I'm required to find the probability that proportion in the sample P at who are looking to buy an SUV is less than 40%. That will be probability that P at is less than 0.40. So I can find the number 0.40. That'll be somewhere here, 0.40. Going to erase this. And with that said, I'm looking at values below, probability in the area below 0.40. So I can go to my normal calculator. So I'm going to go into my calculator. I have keyed in the mean and the standard error, and in particular, I'm interested in the probability in the area below 0.40. So I need to set that into below 0.40 and hit enter button. I have 0.1367. So the answer here is equal to 0.1367. This is the required probability. With that question completed, we proceed to the last question. In this question, we're told that according to the National Center for Health Statistics, 15% of all Americans have hearing trouble. So in the general populace, the general population mean is 0.15. Now, for question A, in a random sample of 120 Americans, what is the probability that at most 12% have hearing trouble? So from the question, in this, let me split this into two columns. In question A, my sample size is 120 and the population proportion is 0.15. My task is to find the probability, capital P, that the proportion in the sample who have hearing trouble is at most 12%. That is, it could be 12%, which is 0.12, but it is no more than 12%, which means it can be less than or equal to 12%. Well, if I want to find a probability connected with the sample proportion, I would need to first find the distribution of the sample proportion. To do that, I will need to check the conditions for using the normal distribution to approximate the sampling distribution of the sample proportions. So, checking the conditions, let me check my conditions first. I will need to multiply n by p, that will be 120 times 0.15, and that will be equal to, that is equal to 18, which is greater than 10, so that checks out. And then I also have n times 1 minus p, this will be 120 times 1 minus 0.15, this is 120 multiplied by 0.85, and this is equal to 102, which is also greater than 10. So with that said, I have met the two conditions. I can definitely use the normal distribution. whose mean in this case is exactly p, which is 0.15, and the standard error of p will be the square root of p times 1 minus p all over n. This will be the square root of 0.15 times 0.85. Since 1 minus 0.15 is 0.85 divided by n is 120. And I will have 0.0326. So with this set, now I have the parameters of the sampling distribution of P at. With that, I can now go back to my question. I would like to locate 0.12, that should be a number below 0.15, and I'm interested in the area below 0.12. So to get that probability, I'll need to key in the mean and the standard error in my normal calculator. So here I go. I have 0.15 and I have the standard error, which is 0.0326. 326, that's the standard deviation. And according to the question, I'm interested in the area below 0.12. So let me set that below 0.12. And I have the answer, which is 0.1787. So the question probability of P at less than or equal to 0.12 is 0.1787, according to the answer we just computed. With that said, let's go to part B of the question. In part B of the question, we're told that suppose a random sample of 120 Americans who regularly listen to music using headphones results in 26 having hearing trouble. Would it be unusual to find that many in the sample who have hearing trouble? Let us see what that entails. What constitutes an unusual event? For the purpose of this introductory class, an unusual event is one whose probability is very low. What is the threshold for a low probability? For this level, we take it to be 5%, 0.05. So if we find that the probability is less than 0.05, we would say that it is unusual. So in this case, we still have what? A random sample of n equals 120 Americans, and the population proportion is still 0.15, and that means that we can still adopt the same sampling distribution for P at. The mean of P at is 0.15, and the standard error of P at is 0.0326. Now at this point, we would like to know if we observe 26 out of 120 who are having hearing problems, is it an unusual event? What we need to do in this case is to compute the probability that P at is at least 26 out of 120. In other words, this is the probability of the sample proportion greater than or equal to 26 divided by 120 is approximately 0.217. So at this point, I'm ready to locate this value. I'm going to locate it to the right of 0.15 since it is bigger. And I'm interested in the area to the right or above that value. And this will be equal to, going back to my normal distribution calculator, this time I want to look at the area above 0.217 with the same specs or the same parameters. So I have 0.0199. So this is equal to 0.0199. Remember, the question is it unusual? This probability is same as 1.99%, which is lesser than 5%. In fact, reasonably less than 5%. So we could say that definitely observing that 26 out of 120 or more having hearing trouble is definitely an unusual event if it is true that in the general population, 15% of all Americans have hearing trouble. So in this case, the correct answer finally would be it is unusual. It is unusual since the probability is very low. That is lesser than 5%.